Hello everyone, I'm Chris McIntosh. I help teach the statistics courses. This week we're going to go over your week 11 computer assignment. The objectives for the week 11 assignment is to conduct a two-way ANOVA in Jamovi, interpret the results for the two-way ANOVA, report the results for a two-way ANOVA. Let's fix that text really quick. And interpret the base factor for the two-way ANOVA. Alrighty. We're going to open our data set in Jamovi, and that's one of the included data sets again. So when you have Jamovi open, you should have already installed the LSJ data module. And if so, then go to the hamburger menu, open data library, learning statistics with Jamovi. Whoops, that wasn't the one I wanted. Okay, let's go to hamburger menu, open data library, learning statistics with Jamovi, and clinical trial. Let's close that one. Okay, if you don't fat finger it, you should get the data set. This is the same one that we looked at for last week. Oh, and add your name to the output. So let's go to analysis, exploration, descriptives, click in front of results and add your name. And click somewhere outside. All right, that looks good. Again, we're using our statistics analysis checklist. Here's our week 11 version for two-way ANOVA. Links there on the slide and in your assignments. Our section 1 questions about the study. Overall, the study purpose. It described that this is an experimental study in the example, but for real, this is a learning exercise, so data are fabricated and results are not generalizable. The research questions is pretty much the same as last week, but we have another variable in there. So participants are randomly assigned to one of three groups: placebo control group, existing medication anxi-free group, and a new drug joyzepam group, and randomly assigned to a therapy group: receive CBT and not receive CBT. And the research question is: mood elevated after a 3-month period taking the drug. It's hypothesized that the new drug will show the largest improvement in mood. Study design, we're told this was a double-blind random assignment control group with manipulation of an independent variable. This would be an experimental design. No ethical considerations were described, and no data collection and handling procedures were described. So the questions in section 2 of our data set, the variables and level of measurement for each one. So we would go to our Jamovi, click on data, and we'll see we have an ID variable that are numbered, a drug variable that has different categories, therapy variable with 2 different groups there, and a mood gain variable. That one would be probably interval level of measurement, because this is kind of a psychometric measurement. And then drug and therapy and ID are all nominal level of measurement. If we got descriptive statistics on these, that's a good way to double check things. This is a small data set. We can see we don't have any missing data. I can review these numbers and nothing looks crazy, and it looks like all of our groups don't have any spelling or typos, but we can go to click on our descriptives that we started, and we'll do our categorical variables first. drug and therapy. And since these are categorical, we want frequency tables, and we can get rid of mean, median, standard deviation, min and max, and we see we have the right number of categories. And let's go ahead and get a plot, and since these are categorical, we would want a bar plot, and we can see that looks pretty good. And we want to get our continuous variable, so we'll go up to analyses, exploration, and descriptives again to get a new output, and we'll put mood gain in. And since we're going to be using factors, I'm going to look at this two ways. I'm going to go split it by drug, and we can see we get means for the different groups and standard deviations. And let's go ahead and get plots, histogram and box plot. We can see we have these different drug groups and showing with the box plots. And let's go ahead and do a separate one and do mood gain by therapy. So we'll go to analysis, exploration, descriptives again. And let's put mood gain in, and this time split it by therapy. And we see we have means 1.04 and 0.77, so the CBT group is a little higher. Standard deviations 0.45 and 0.587, not crazy differences in our standard deviations, our variability. So I suspect we'll probably pass the Levine's test when we look at it. And let's go ahead and get our histogram and box plot for those. A little higher on the histogram, a little higher on the box plot, but not too many differences. All right, so our data accuracy looks good. We didn't have any data manipulation to do, and no missing value, no outliers. And we took a peek at our descriptive statistics. So this is our section number 3, our test information. So which statistical test are we going to look at? So we updated our which test should I use table. And so if you scroll down this one, we have our one variable table, and then we have our one dependent variable and one independent variable. And I went ahead and added a new table just to try and keep things a little cleaner looking. It gets hard to see all these things put into the same table at once. So this new one is one dependent variable and more than one independent variable. So we're going to have that with our two-way ANOVA. Again, our outcome variable is continuous, so we're going to roll a ratio, and our independent variables are nominal or ordinal, or categorical. And so we put that here, two categorical independent variables, two-way ANOVA. If we have skewed data, we'll talk about this. You could fall back to two separate one-way ANOVAs, non-parametric equivalent, which is the Kruskal-Wallis test. But we don't have a real two-way ANOVA non-parametric equivalent because there just isn't one for a two-way ANOVA. But we'll talk about it in our slides in just a moment. Let's see. StatCat, we can take a peek in Jamovi and see if Jamovi can give us, picking the right data set here. See if Jamovi can give us a little bit of help. So if we click on StatCat, and we're going to relationship prediction and group comparison. So this is group comparisons. And our dependent variable is our continuous variable mood gain. And our independent variables are drug and therapy. And when we put those in, we see that StatCat gives us a two-way ANOVA as a test And I bet if you went into ChatGPT and asked what kind of test could I do with a continuous dependent variable and two categorical independent variables, I suspect that ChatGPT would probably do a decent job of recommending a two-way ANOVA also. Excuse me. Our test assumptions for a two-way ANOVA, they're pretty much the same as a one-way ANOVA. Our sample is randomly selected from a population. We know that from the sampling design, which we didn't get described for us here, but we'll make some assumptions. Observations are independent. That is known from the study design, and that's what was described to us. Data are normally distributed, and that's kind of a simplification of the assumption. In reality, it's the residuals are normally distributed, but we're not getting into too much detail here, so that's okay for now. And homogeneity variance, which means that the variability in our different groups is basically the same, and we'll test that out. Let's go ahead and check our assumptions. So let's go ahead and go to Analyses, ANOVA, and we'll go to the ANOVA menu. It's the second one on there. And our dependent variable is our mood gain. And now our fixed factors are both drug and therapy. And let's click on the box for assumption checks and get homogeneity, normality, and QQ plot. And just so we check it, homogeneity variance, Levine's test is not significant, so we pass our homogeneity variance assumption. And our Shapiro-Wilks for our normality is also not significant, so that would seem to pass. And our QQ plot data points are fairly closely lined up with the normal line. So we're okay with our assumptions. So now we can calculate our perform the steps of null hypothesis significance testing. And our first step is to state our null and alternative hypothesis. Excuse me. And you'll notice here that we have three sets of null and alternative hypotheses. One is for the interaction, which automatically gets added to our model. And then one is for our first main effect, which is our first factor or our independent variable for drug. And the second is our second main effect, which is for our second factor therapy. And the interaction, the null and alternative is, the null is there's no interaction between the factors, and the alternative is there is an interaction between the factors. And as noted in the lecture, if you listen to that already, this interaction really is the important part of a two-way ANOVA. Otherwise, you can pretty much test each factor on its own with a one-way ANOVA, and you don't get that interaction test. But here in a two-way ANOVA, we do get that interaction test. And you'll notice here in the output, I'll point this out, that we have drug and therapy, and then we have this drug asterisk therapy. So that one variable with an asterisk and another variable is the interaction. And we haven't done regression models yet, but literally when you do an interaction between two variables in a regression model, it's literally multiplying one variable by the other. You create a third variable with that multiplication, and you can add an interaction to a regression model. So literally you do multiply them by each other. So that notation is not really an accident. So we have our null and alternative hypotheses, and really the first thing that you look at is the interaction. That's the first thing that you interpret. We're still using our alpha 0.05. You'll notice here under our test statistic, I've added a line for the interaction and a line for each factor, because you're going to go want to look at the F statistic with degrees of freedom and the F value, and the p-value for each one. So since we're here, let's go ahead and take a peek at this. So for our drug therapy interaction, that's the first thing that we would look at. We have an F statistic of 2.49. That's not a very big F statistic, and a p-value of 0.125. In this case, the interaction is not significant, and then you would go on and look at each independent variable, each factor separately on its own, and kind of treat it and interpret it as if it were a one-way ANOVA, and you can go select post-hoc tests. But I did want to look at this interaction just a little bit because understanding that while it's not significant here, if you did have a significant interaction, you definitely want to spend time understanding what that looks like. And Jamovi gives us a way to actually look at a plot of this. And so if you click on the estimated marginal means menu, and you'll see that we have our two factors listed and then this term over here. If you drag each one over to the term 1 box, drug and therapy, what that does, and then down here you'll notice that it says marginal means plot, and so it takes the mean of each group and splits it out in the chart by one variable in the x-axis, and then it splits the other variable into separate lines. And we can see the yellow line here is no therapy, and the blue line is the CBT group. And you can see that these lines are not actually parallel. So when you don't have parallel lines and you know, they're not really crossing each other, this does happen to cross, but it's not crazy. It's kind of a question of degree, and in this case it did the test and said it wasn't statistically significant, but if we'd had a larger sample size, this very easily could have been a significant interaction because our p-values are dependent on our sample size. We can actually get the marginal means tables. I missed this last week just because it didn't say descriptives, but that gives us the mean and standard error for each individual group. Split out, there's our therapy, CBT and no therapy, and then our drug subgroups in each one with descriptive statistics for that. So that really is really helpful. This plot is really the main way that you understand an interaction, because we have 3 groups in one variable and 2 groups in the other. This is not too hard to pick apart. When you get more groups, it gets a little complicated, and so you really want to spend some time looking at, you know, what's the difference here. And if we just take a, you know, summarize what's the trend here, and it would be that joyzepam definitely has higher mood scores than the other 2 groups. And then among you'll see the no therapy groups are all a little lower than the CBT therapy groups, especially in the anxiety-free and placebo groups. Those were higher. So just a little difference. So that's one way that we can understand that interaction. If we're going to report statistics for these, we would say that our interaction was not significant, and then we'd say that drug was significant and report our F with our degrees of freedom of 2 and 12. For our interaction, the F would be 2.49 with the degrees of freedom of 2 and 12. And for therapy, it was also significant with a degrees of freedom value of 8.58, degrees of freedom of 1 and 12. And I believe when I was reading in the Navarro text that they did an example with just therapy, and on its own it actually was not significant. So when you leave out other important things in the model, sometimes that variability gets put into the residuals, and it looks like it's not quite as important, but when you've added other important variables in the model, then sometimes something that wasn't significant will be. So that was interesting to note in the readings this week. Post hoc tests, we would look at our factors, and we could get a Tukey on each of our main effects here. And if we go down, let's see how that looks. Okay. So you'll see that we have our post hoc for drug. That looks just like it did last week. And now we have a post hoc test. There's only two groups, so there's only one pairwise comparison there. And we can get a Tukey, and we can see that we still have that same value that we had. So really, this really is like two separate one-way ANOVAs at this point, because they're without a significant interaction. Then you would just interpret each one as if it was a one-way ANOVA, so you could report the post hoc tests on that. And effect size, you can add that in. I'm just going to do a partial eta squared, and you'll notice that up in our ANOVA table now we have a partial eta squared. Still pretty large effect sizes there, given how those are normally interpreted. And a Bayes factor. So we know that we don't have a checkbox for a Bayes factor here, but we did install the Bayesian analysis last time under modules, and it was the JSQ Bayesian methods. And so we can go to analyses, ANOVA, and down here to Bayesian ANOVA. And really, we're just interested in getting a Bayes factor out of this, but we can move mood gain to the dependent variable, and drug and therapy to the fixed factors. And you'll notice that we get Bayes factors here, and but we do have multiple models. So what this is the null model is just, it doesn't have any variables in it yet. And then you can see we have drug, therapy on its own, and then we have a drug plus therapy, meaning that it's a model that just has drug therapy, but we're testing this drug plus drug therapy interaction. That's the model we have. So the Bayes factor is this 674.5 Bayes factor. I'd probably just round it up to 675, because I don't think that decimal means a lot. So we can get a Bayes factor on that. Okay, so what is the story the data are telling us? So the interaction between drug and therapy was not statistically significant. That's probably the first thing we check. The main effect of drug was statistically significant, and joyzepam showed a greater mood elevation than the existing medication and placebo. And the main effect of therapy was statistically significant. Those receiving CBT showed greater mood elevation in the anxiety-free and placebo groups compared to those not receiving CBT. So you just kind of want to describe the trend or pattern for the reader. So reporting results, we're going to go ahead and try this out. And I noted in your lecture, I kind of gave you an example of reporting it. This is complex enough that I would definitely, if you were wanting to do this, I'd go double check it with a statistician, just to make sure that you didn't miss anything, because these analyses at this point do get a little more complex. So it's good, but I think it's good to let's see how ChatGPT does with this. This is where the LLMs. I've been a little surprised at how well it's done so far, but I'm going to go ahead and we will give our example prompt that we've used. Used a couple times here. So there's our first prompt, and shift enter to go down to the next line, and then we'll get our Jamovi So there is our ANOVA table with our interaction and main effects. Copy that and Control V to paste. Shift Enter to go to the next line. I'm not going to worry about the assumption checks because we passed them. So let's just try this without that. We'll copy our post hoc tables. Control V to paste, Shift Enter to go down to the next line. And our estimated marginal means table, let's give it a shot. Truly, this is an experiment. These tools are new and I have not used them before, and I'm just going to report a Bayes factor of 675. BF10 equals 675. See if it understands that that's a Bayes factor. This will be interesting to see. Okay, so we have some descriptive statistics. Two-way analysis of variance was conducted to evaluate, I don't know how to get rid of that box, the effects of drug type and therapy type on mood gain. No significant main effect of drug type, no significant main. Oh, looks like ChatGPT did not interpret these output quite as easily, which doesn't surprise me because the more complex you get, the harder it gets. Significant main effect of drug type F212, 31.7. That looks pretty good. Significant main effect of therapy type was also found. 8.58 PO, that looks pretty good. I pulled that out correctly. It says the intersection was not significant. So interesting that it says these were not significant and then it gives significant effects. So definitely you want to be careful looking at these results. I think it's still doing a halfway decent job, but you don't want to just copy and paste this without evaluating what it says. These findings suggest that both drug type and therapy type are independently, I don't know how to get rid of this. Got it. Okay. These findings suggest that both drug type and therapy type independently contribute to mood gain. Joyzepam was the most effective drug, significantly improving mood gain compared to both anxiety-free and placebo. Similarly, CBT led to higher mood gain compared to no therapy. However, the combination of drug type and therapy did not produce statistically significant interaction effect, indicating that benefits of the drugs were consistent across therapy conditions. That's a nice summary of that interaction. This study provides evidence of both pharmacological Joyzepam and psychological intervention CBT are effective in improving mood. Future research could explore potential moderating factors that might influence the interaction between drug type and therapy and mood enhancement. So pluses and minuses on this one, but despite, I don't know what this 1, 2, 3 comes from, but the rest is okay. So go ahead and copy your sample write-up and let's paste it into our Jamovi output down here at the bottom. Click at the bottom below the tables until you see the cursor and hit Control V to paste. And then you want to hamburger menu and save the OMV data file, and then go to hamburger menu and export your PDF. Go to browse and wherever you're saving your stuff in your folder, and export your PDF. And then answer your computer assignment questions and submit your PDF in Canvas. So nice job, you guys. This is a little bit more complex of an analysis, but I just wanted you to see that interaction, and because that's something that's new. And you might see two-way ANOVAs reported in the literature, so good to understand what's going on with those. Have a good week, and we'll talk to you later.